Hello to everyone. My name is Karthik. Today we are going to see half subtractor and full subtractor. For half subtractor, combinational design procedure. We require three logic gates for making half a subtractor circuit, namely the XOR gate, NOT gate and NAND gate. The combination of and NOT gate produce a different combined gate named NAND gate. The XOR gate output will be the difference bit and the NAND gate output will be the borrow bit for the same inputs A and B. Objective. The half subtractor is constructed using XOR gate and AND gate. The half subtractor has two input and two outputs. The outputs are difference and borrow. The difference can be applied using XOR gate. Borrow output can be implemented using an AND gate and an inverter. Input and output variables. Input variables is equal to a comma b within bracket either 0 or 1. Output variables is equal to d comma b where d is difference and b is borrow. The truth table. When input a is 0, input b is 0, the borrow is 0, the difference is 0. When a is 0, when b is 1, borrow is 1 and difference is 1. When a is 1, b is 0, borrow is 0, difference is 1. When a is 1, b is 1, borrow is 0 and difference is 0. This is the K-map for half subtractor. This is the circuit design for half subtractor. Two input switches, one XOR, one NOT and one AND. Full subtractor. Combinational design procedure. The full subtractor is a combination of XOR and or NOT gate. In a full subtractor, the logic circuit should have three inputs and two outputs. The two half subtractor put together gives a full subtractor. The first half subtractor will be C and A B. Objective. Full subtractor is a combinational logic circuit. It is used for the purpose of subtracting two single bit numbers. It also takes into consideration borrow of the lower significant stage. Thus, full subtractor has the ability to perform the subtraction of 3 bits. Input and output. Input variables a comma b within bracket either 0 or 1. Output variables d and b where d is difference and b is borrow. Truth table. The input a input is 0, b input is 0, b in is 0, the borrow is 0 and the difference is 0. When a is 0, b is 0, b in is 1, the borrow is 1, the difference is 1. When a is 0, b is 1, b in is 0, the borrow is 1, the difference is 1. When a is 0, b is 1, b in is 1, borrow is 1 and difference is 0. When a is 1, b is 0, b in is 0, the borrow is 0, the difference is 1. When a is 1, b is 0, b in is 1, the borrow is 0 and the difference is 0. When a is 1, b is 1 and b in is 0, the borrow is 0, the difference is 0. When a is 1, b is 1 and b in is 1, the borrow is 1 and the difference is 1. This is the K-map for full subtractor. This is the circuit design for full subtractor. We are doing full subtractor now. Let's take two switches. Three switches. Let's put an XOR gate. an AND gate, a NOT gate, another NOT gate, a- an AND gate, an XOR gate, an OR gate, for outputs we are taking the light bulbs, we will label them to label this for in XOR not and not and or XOR. Difference, the last one, borrow. We're going to connect A to XOR, connect A to the NOT. We're going to connect B to the XOR, and connect B to the and we are going to connect borrow in all the way to the XOR. We are going to connect borrow in all the way to the and the NOT to the and the XOR to the NOT and the XOR to the other XOR and the NOT to the connect to the OR, connect the other to the OR. We'll connect OR to the borrow out and XOR to the difference. Turn on switch A. We are seeing there is difference 1. Turning on B, we have both difference and borrow out. Turning on A and B, there is no difference and no borrow. Turning on borrow in, we have both borrow difference and borrow. Half subtractor, we are using two switches here. We are using a XOR gate. We are using another AND gate. A NOT gate. A light bulb for output. Another light bulb for output. We are going to label these switches and the gates. We are naming this switch A, switch B. This is not gate. XOR gate. AND gate. This is difference. This is borrow. We are doing half subtractor. So let's connect. Connect it with XOR gate. Another one with NOT gate. Let's connect switch B to AND gate. Let's connect it to XOR gate. And the output of NOT gate to AND gate. And the output of XOR gate to the difference. And the output of AND gate to borrow. Let's turn on the switch B. So you can see the difference and borrow are lightened up. If we turn on A, the difference is on. We turn on both, there is no difference or borrow.